Welcome to ClickMyProject.com. Our title is Delay Optimal Scheduling of Virtual Machines in a Queuing Cloud Computing System with Heterogeneous Workload. This is our abstract. In our process, explain virtual machine scheduling in a queue cloud computing system with stochastical arrivals of heterogeneous job by considering jobs, delay requirements. The delay optimal virtual machine scheduling in such a cloud computing system is formulated as a multi-resource, multi-class problem, minimize the average job completion time, which is often NP-hard. To solve such a problem, we first propose queuing model that buffers the same type of virtual machine job in one virtual queue. The queue model then divides the virtual machine scheduling into two parallel low complexity algorithms, that is intra-queue buffering and intra-queue scheduling. We further propose a queue length based MaxWeight policy based on Lyapunov drift to minimize the queue length of the virtual machine jobs, which is called SJF-QMW. Here, this is our system architecture. First, we should start our process. After starting our process, the cloud users will log in this portal. If you are an existing user, you are directly go to login. Otherwise, I should register in this portal. After login process, the cloud user should create a data center. After creating data center, you should create a broker ID. After creating the broker, then we creating a virtual machine. In the process of virtual machine creation means how many virtual machines are used to process in our optimal algorithm that the virtual machines are creating in this process. After the virtual machine creation, we are creating a cloudlet. Cloudlet means how many jobs are assigned to virtual machine. Means here we are creating a jobs, and after the cloudlet creation, the jobs are sent to task manager. Then task manager should log in this portal, then receive a task from cloud user, and after receiving the task manager calculate the load balancing of task. Then the SJF-QMW algorithms are implemented here. Then the result are displayed, and after finding the result, we are creating a comparison graph. And now we start a demo session. Before starting a demo, we should run our WAMP server first. Start our WAMP server. Yeah, WAMP server is started. After starting a WAMP server, it can run your process. So first you should run homepage.java file. Run that file. Yeah, this is our home page, and click next button. Yeah, this is a cloud user login page. If you are an existing user, you are directly going to login. Otherwise, here you register your detail. Yeah, now the user details are entered here, and now you click to register. Yeah, registered successfully. Now we should log in this portal. Click the login button. Login successfully. Here we enter the data center creation. How many data centers are used to in our process? Means here we enter the data center. Yeah, data center are created. Now we click to broker creation. Yeah, click to OK. Next we are going to virtual machine creation. Click to create a virtual machines. Virtual machines are submitted respective broker successfully, and here we should enter the jobs. How many jobs are in our process means here we enter jobs. Yeah, we enter a job. Next we upload file into cloud. Here the file limit is 88. Here our file limit is 8. So we have to choose a file. Yeah, 8 files are selected. So file uploaded to schedule. Here our selected files are into database, and here we enter the deadline, like we enter 60 minutes and send request to task manager. Yeah, request send to task manager and click to task manager. Here task manager should log in this portal. Choose to log in. Yeah, task manager should receive in this task. Yeah, receive the task, uploaded file to virtual machine, and here the load balancing calculations are done. Yeah, it's arranging to ascending order, then job allocation, calculating load balancing allocation here, and next we click the job allocation. Here we implement SJF-QMW algorithm and click to, yeah, the process is done. Here the algorithm is implemented, so all processes are done. This is a ending time, okay, process ending time. And graph comparison, this is a graph comparison. Here we calculate efficiency, time duration, and resource utilization, RAM, speed, and overall cost. Okay, thank you.